secured All India rank 9th in the GATE examination and completed my Masters from the Indian Institute of Science, Bangalore. Good afternoon, Bhargav, and it's been more than 11 years of me training the students for ESE GATE and various technical examinations. Okay, everybody. So that is what, if you want to enroll for the exclusive, if you want to prepare exclusively for the GATE, the Vision GATE batch is live. The Vision batch for ESE GATE and PSUs, and for the first second year beginner student, the Vision 23 is also live. Good afternoon, Sandhya. Okay, so the booster BARC course also available on the Gradeup Super for practice and revision. The GATE 22 champion study plan for the self-study students, daily theory classes, practice classes, quizzes, study notes, everything being provided in a systematic manner. Okay, taken up by the India's best faculty team, and this is what is the lead star faculty team of electronics, the best in the nation. You can see 15-20 years of experience, top rankers and all, the best qualified faculty team. And to avail the PDFs of my session, like today's PDF, whatever questions we discuss in the signals, okay, the PDF of the session, right, for doubt discussions, for class notifications, personal interaction, daily quizzes, you can just join the Telegram group gate/ESE by Rakesh Talreja and have fun. Okay, just have fun learning and doubt discussing. Okay, even the PDF of the today's class, I will share it in this Telegram group. Okay. Yes, very good afternoon, everyone. Once again. So guys, let us get started with the question. But the attendance, what guys, the same thing I asked EMT on the EMT day, whether this BARC, the booster BARC, whether, let me see whether people, how much are looking for the booster BARC. Chalo guys, begin karte, everybody. Find the energy of this. So some important questions we'll discuss. Okay, and we'll revise through these important questions as per the level of the BARC. Good afternoon, Samantha. Okay, so find the energy of this signal. So how do you find out the energy of this signal, guys? Remember some shortcuts to find out the energy and then the power. What is the shortcut to find out this energy? What should be the shortcut to find out the energy, everybody? What should be the shortcut to find out the energy? Okay, have a look at this. कैसे इसको निकालेंगे? तो first to find out the energy, let me tell you some simple rules. Okay, some simple shortcuts. So there are three shortcuts that you should take care of. There are the three shortcuts that you should take care of. Sir, what are the three shortcuts which are going to be very helpful for you? There are the three shortcuts which will be very much helpful for you, and then you can solve the question. Everybody. Okay. Number one, if you have a rectangular pulse, okay, having the duration d and amplitude a. Next, you have a triangular pulse, okay, located at any point on the time axis. Duration matter karta hai, only what is the total duration and what is the maximum amplitude, height of the triangle. Okay, or if you have a half wave sine, okay, having the duration d and the amplitude a, right? A rectangular pulse, a triangular pulse and a half wave sine. Okay. So basically what is the energy is a square into d for the rectangular pulse. What is the energy for a triangular pulse? It should be a square d divided by 3 directly, otherwise people will start integrating and all. So direct likhenge. And the energy for the half wave is a square d by 2. Okay, directly these are the shortcuts that you should apply to the question. So what is the energy of this signal? No, these questions just to be solved within 1 minute, within a minute. So what is the energy of this signal? Sir, the energy should be a square. Now first a triangle. Okay, let's break it into part number 1, part number 2 and the part number 3. So I can write down the energy as E1 plus energy of second signal, energy of the third signal. What is the first one? A square d, 2 square into 2. Right, amplitude a square d by 3, triangle and amplitude 2 and base is 2. Okay, plus next is a rectangle, amplitude 2 and duration 2, 0 se leke 2, ye 2 hai, ye 0 hai. Right, and next is again a rectangle having the height 4 and duration 2 se leke 4 is 2. Okay, this should be the answer, everybody. This should be the simple answer. So this is 8 by 3 plus 8 plus 32 and 40 plus 8 by 3, 8 by 3 plus 40. And this becomes 128 by 3 joules is the answer. 128 by 3 joules, or you can say basically 42.67 joules is the answer for the question. 42.67 joules is the answer for the question. 42.67 is the answer for this question. Simple? Chalo. Next question. So I've just taken a gate reference question here. Find the mean square value. What is the mean square value? Yes, correct, Charu. What should be the mean square value? Mean of the squares. That is basically the power. That is basically the power. Time average power. Mean square value means you just have to calculate the time average power. And how do you calculate the power for periodic signals? Okay, for periodic signals, let us learn another formula and then solve this question. For periodic signals, how do you calculate the power? The net, the time average power, or simply the power, is calculated by the shortcut. Calculate the energy for one time period. Energy for one sample for one time period divided by the value of the time period. Energy for one time period divided by the value of the time period. Divided by the value of the time period, everybody, right? Divided by the value of the time period. So, kitna ho jayega? Now see, time period means the time for which the time for repetition. So, what should be the repetition point? So, I can start with this. You can start from anywhere. So, I will start this rectangle. Okay, then there's a constant, then there's a decline, then again a constant, up, and then here. Then this is what is the repetition actually. Okay, so this particular gap marks my time period, and so my time period is minus 0.3, so 3.7 is a gap of 4. My time period is 4 seconds, right? Okay, so what is my power? Okay, energy in one time period. So now in one time period, first of all, I get a rectangle. Energy of rectangle, a square d. Same shortcut you will apply. Energy for the rectangle is a square d. Okay, first, the 4 square into duration minus 0.3 is 0.7, 1. Okay, then again a rectangle. Whether the amplitude is negative does not matter, because even when you take the square, it becomes a positive only. So even if you take minus 2 square, it is same as 2 square, duration 2 hai. Okay, and plus 0. This is a flat part. 0 signal, so 0 energy. Okay, whole divided by the value of the time period. So 4 square is 16 plus 8 divide by 4. Okay, 24 by 4. Answer should be 6 watts. Everybody check your answers. Answer should be the 6 watts. Everybody. Okay, everybody. So this is also one expected question here. This is also one expected question here. Okay, moving ahead to the next. Moving ahead to the next. 6 watts power hai, Charu. So not joules. Joules for energy, watts for power. Joules for energy, watts for power. Okay. Correct. Next question. Number 3. Convolute. Okay, convolute xn equal to 1, 2, 1, 1 and 1 minus 1, 0, 0, 1. Okay, let me clarify this signal actually for you. What is the signal xn? Xn is 1, 2, 1, 1. Where you see this 1 as bold. Now, to represent the origin of the discrete signals, we should know, to represent the origin of discrete signals, either they can bold that variable, bold that value, or they can apply an arrow. So this bold value, this is what is the origin. Okay, this will represent the value at origin. And similarly, Hn mein first value we bold hai, so it will be 1 minus 1, 0, 0, 1. Okay, and this is the origin, n equal to 0. Now, how do you convolute to finite? How do you convolute to finite discrete time signals? Okay, apply the sum by column method. Sum by column. Kya karenge sum by column method mein? Okay, write down the value of the signals of one of the signals on the top. 1, 2, 1, 1. 1, 2, 1, 1. And write down the value of the other signals. Okay, across the side. 1 minus 1, 1 minus 1, 0, 0, 1. We should know that convolution is commutative. So किसी को भी आप top पे लिख सकते हो, किसी को भी side पे लिख सकते हो. It does not matter. It does not matter. So now I multiply by 1. So this is 1. 1 into 2, then 1 on 1. Multiply by minus 1, and when you multiply by the next element, write down results right shifted. Write down the results as right shifted. Right shift करके लिखेंगे. तो minus 1 into 1, minus 2, minus 1, minus 1. Next 0, 0, 0, 0, 0. Next again 0, 0, 0, 0. 4 times, na? Sorry. 4 samples. Then multiply again by 1. 1, 2, 1, 1. 1 unit right shifting. Every time 1 unit right shifting. And now sum by column. Now sum by column. Right, everybody. So this is 1. Add up all the columns. 2 minus 1 is 1. 1 minus 2 minus 1. 1 minus 1 0. Minus 1 plus 1 0. This is 2. This is 1. This is 1. So what should be the output? What should be the result of the convolution? Yn, which is x of n, convolution h of n, and this is given by 1 minus 1, then 0 0, 2 1 1. 2 1 1. But this will not complete my answer. This will not complete my answer. Okay, where is the origin of the output? Which sample is at origin? Where is the starting? तो अब आप एक याद रखना point. How do I mark the origin? If this is n equal to 0, so this will be n equal to minus 2. Going left na minus 1 and minus 2. This is n equal to minus 2. Sum of the starting point. Okay, what is the sum of the starting index of convolution? Okay, the output should start at, it starts at the sum of the starting points of xn and hn. So xn is starting from minus 2 plus hn starts with 0. hn starts with the origin only. So sum is minus 2. So this should be n equal to minus 2. This is what is n equal to minus 2. So go ahead. Minus 2, minus 1, 0. So this is what is your origin. This should complete the answer. Okay. Without the origin, we can't say it is the complete answer, everybody. So I मैंने origin mark कर दिया. Okay. Then there are some more properties that you should remember as a properties. That what is the length of y? See, what is the length of y here? How many samples in the y? 1, 2, 3, 4, 5, 6, 7, 8. That is equal to 8. Correct? And you see how many samples of x? 1, 2, 3, 4. How many samples of h? 1, 2, 3, 4, 5. And this is equal to 4 plus 5 minus 1. Correct. In general, length of y is length of x plus length of h minus 1. Correct hai? Chalo. That is what is the general property for the length, for the sequence. Now let yn denote the convolution of hn and gn. Okay, where yn, see guys, in these days BARC discrete time questions are more common, so that is why ये convolution and discrete time questions को ज़्यादा focus कर रहे हैं. Okay, anyways, most expected questions we are practicing. So let yn denote the convolution of hn and gn, where hn is half power n un and gn is a causal sequence. If y0 equal to 1 and y1 equal to half, what should be the value of g1? Okay, इसको भी shortcut से solve कर सकते हैं. Right, what is the hn? Yn denote the convolution of hn and gn. hn is half की power n un. मतलब I can write down hn as, if I want to write down in sequence, half power 0 is 1, then half power 1, half power 2, half power 3, etc. But this goes on till infinity. Okay, and gn is a causal sequence. Okay, gn is a causal sequence. It will have the value g0. Causal means what? gn is a causal sequence. इसका क्या मतलब है? gn is a causal sequence. It means that g of n equal to 0 for n less than 0. That is what is the meaning of a causal sequence. gn equal to 0 for n less than 0. That is why I am starting with g0 directly, then g1 and g2 and etc. So if I solve by the shortcut 1, देखो method number 1 is formula. Okay, method number 1 for this question is formula. Breaking up the formula, y of n is summation of hk g of n minus k, or you can do it reverse also, summation of gk hn minus k. Right, that is what is the general convolution formula, but I can make it little more simple. Okay, the formula number 1, ये हो गया method 1, that is the formula. Now going to the next case. Okay, method number 2, again I am trying to do the sum by column here. Okay, because only one of the value is asked, so that can be solved by the sum by column. अब देखो क्या करेंगे हम यहाँ पे. Let me write down these values here. Let me write down any one of the values on the top. So let us write down these values, g0, g1, g2 on the top, and let us write down the values 1 half, 1 by 4, 1 by 8 on the side. अब देखना what is given to you, y0 and y1 is given, एकदम easily solve होगा ये. Okay, this is g1 multiplied by all the samples, then half multiply करेंगे तो यहाँ नहीं, sorry, right shifted, half of g0, half of g1, etc. Then 1 by 4 g0, but again right shifted, 1 by 4 g0 and etc. But I don't want the complete samples. If I start doing sum by column, this is g0, right? This is g1 plus half g0. Question solve यहाँ पे, and etc etc etc. This corresponds to y0. ये output का first sample है, and this corresponds to y1. Because hn and xn both are starting. ये है ना hn. hn starts with un, that is n equal to 0. gn is also a Gaussian sequence, that also starts with n equal to 0. Because the xn and hn are both starting with n equal to 0, output should also start with n equal to 0. So that means this is y0. Okay, तो clear answer आ गया ना. y0 is equal to कितना given है? y0 is 1 and that is equal to g0. Next, y1 भी given है मुझे. What is y1? Is half. And that should be equal to g1 plus half g0. g1 plus half g0. So 1 by 2 is equal to g1 plus half of g0. And what is the g0? ऊपर से लिया 1. Half and half cancel. g1 equals 0. g1 equals 0. What is the correct answer, sir? Option number A. The correct answer is exactly the option number A, everybody. The correct answer is the option number A. This is a decent, it's a good question of convolution to be solved very easily. इसको easy कैसे solve करना है? That is what our process is. That is what our process is. Correct? चलो, cool. Next question. Convolute un plus 1 and un minus 3. Okay, in the terms of r, यहाँ पे मैं लिख देता हूँ to make it clear. U is the unit step. U is for unit step, and in the options R is to represent unit ramp. This should be simple. Can you tell me the answer, guys, quickly? Can you tell me this answer quickly? This should not be difficult. This should be simple. And what is the answer? Okay, everybody. Yes, let us see this. We have to be very careful, because what is the result actually? Actually, what is the result that you have to recall? What is the convolution of step with step in the discrete domain? Un convolution un. What is the step convolution step? देखो यहाँ पे wrong answers आ रहे हैं. In the discrete domain, guys, step convolution step is r of n plus 1. It is rn plus 1. Right? If it is continuous domain, in the continuous time domain, the results are different. Okay. U of t, convolution u of t is rt. Okay. But in the discrete domain, un convolution un is r. Is rn plus 1. Okay. So that is why maybe we can make the mistakes. That is why. So what should be the correct answer? Let's solve it here. So sir, if un convolution un is r of n plus 1, question is asking u of n plus 1. Convolution u of n minus 3. Time shifting property should be r of, now n plus 1. Whatever time shifting is done to any one of the signals, same is applied to the other signals. So n plus 1. Okay. Not only n plus 1. n में गया plus 1 and then minus 3. And already this plus 1 is separate. ये plus 1 तो separate चलेगा. I have done the time shifting on the n. So this now becomes r of n plus 1 minus 3, n minus 2 plus 1. So n minus 1 effectively. r of n minus 1. Correct answer is B. देखो धोखा हो गया. This is a simple question. This is a simple question where we can get little bit of the dhoka. Pranam Shubhadeep. Welcome to the session. ओके, दिस इज व्हाट इज Rn-1, तो थोड़ा सा केयरफुल होना पड़ेगा यहां पे, थोड़ा सा केयरफुल होना पड़ेगा. चलो कूल. Right, next one. If ft is a real and odd function, okay, एक Fourier transform based question आ रहा है. If ft is a real and odd function, its Fourier transform will be very expected question and very common, expected in all type of exam. If ft is real and odd function, its Fourier transform is pure imaginary and odd function. Okay, pure imaginary and odd function. Pure imaginary and odd function. Okay, if ft is only real, Fourier transform is conjugate symmetric. If ft is real and even, Fourier transform is also real and even. If ft is real and odd, Fourier transform is imaginary and odd. If ft is conjugate symmetric, duality apply करें. If ft is conjugate symmetric, the f omega is real. ठीक है, these can be simple expected points. These can be simple expected points. Next question. Again a property based question to be precise. Let xt has the Fourier transform x omega. What is the Fourier transform of x of 5t minus 3? X of 5t minus 3. X of t having the Fourier transform x of omega. What is the Fourier transform of x of 5t minus 3? The x of 5t minus 3. xt has the Fourier transform x omega. Fourier transform of x of 5t minus 3. So check करें. So first do the shifting. X of t minus 3. What is the Fourier transform of x of t minus 3? X of omega e raised to the power minus j3 omega. Time shift, frequency में phase term. Right. Then x of 5t minus 3. X of 5t minus 3. X of 80. X of 80, t की जगह 80, तो 1 upon a, 1 upon modulus of a, that is 5, right? 1 upon modulus of a, x of omega by a, तो x of omega by 5, and here also जितने भी omega हैं will be replaced by omega by 5, correct? These are the two properties used. So 1 by 5, x omega by 5, e power minus j3 omega by 5. Okay, x by 5, 1 by 5 x omega by 5 e power minus j3 omega by 5. Correct answer is option number A. Option number A. Sandhya, A. It should be A, not the D. Correct answer is A. Okay. Yes, Charu, correct. The correct answer is A. So what are the two properties that I have used here? X of t minus t naught has the Fourier transform x of omega e power minus j omega t naught. X of 80 has the Fourier transform 1 by modulus of a, x of omega by a. Okay, x of minus t, अगर minus t होगा folding, will have the Fourier transform x minus omega. Some useful properties of Fourier transform, right? चलो next one. The Fourier transform, a very common question and very important. The Fourier transform of a rectangular pulse. Then इस पे numerical भी लेंगे हम लोग. It's nice, Sumit. BITS Hyderabad embedded system is good. The Fourier transform of a rectangular pulse is a sinc function. Sinc function or a sampling function, जैसे भी आप express करना चाहो. The formula is rect of rectangular pulse. Rect of t by t has the Fourier transform sampling ओमेगा टी बाई 2. अच्छा, सैम्पलिंग के फॉर्म में भी लिख सकते हैं, सिंक के फॉर्म में भी लिख सकते हैं. ओके, फर्स्ट ऑफ ऑल, व्हाट इज द मीनिंग ऑफ दिस रेक्ट टी बाई टी? व्हाट इज द मीनिंग ऑफ दिस रेक्ट टी बाई टी? Whenever I want to express the rect of t by t, what does it mean? It means a rectangle centered at origin and having the total duration t. Minus t by 2 say t by 2, the total duration is t. Okay, the total duration is t. And that is given by the formula sampling. Fourier transform is sampling omega t by 2. Now, what is a sampling function, guys? What is the sampling function? What do you mean by sampling x? Sampling x simply means sin x upon x. Whereas, what is the representation of the sinc function? Sinc function is written as sin pi x divided by pi x, correct? Sampling x is sin x by x, right? Sin x by x or sin pi x upon pi x is the sinc x. तो देखो, अगर यहां पे मैंने pi रखा, what should be sampling pi x? Everybody, sampling pi x is sin pi x upon pi x. Okay, that means the sinc x is also equal to sampling pi x. Same expression. The sinc x equal to the sampling pi x. Okay. और अगर सैम्पलिंग की बात की जाए तो इट इज इक्वल टू सिंक ऑफ, अगर सैम्पलिंग लिखना है तो सैम्पलिंग x शुड बी सिंक ऑफ x बाई पाई, सिंक ऑफ x बाई पाई, तो यहां पे डिवाइड बाई पाई कर दिया. यू कैन राइट डाउन द ओमेगा एज 2 पाई f. You can also write down the omega as 2 pi f. So 2 pi cancel. It can be sinc ft in the form of f. It can be written as sinc ft. I think BITS हैदराबाद. वैसे दोनों ही अच्छा है, दोनों ही अच्छा है सुमित, but BITS हैदराबाद is good I think. Sinc ft. Okay. चलो next question. Next question. Which can be based on this. Which can be based on the discussions we have done and a property based gate का question लिया है एक. A signal is represented by xt equal to 1, mod t less than 1 and 0 for mod t greater than 1. So what is first of all this signal? What is first of all this signal? What is this signal first of all? एक बार quickly signal को बना ले. It is equal to 1 for mod t less than 1. Mod t less than 1 मतलब modulus of t less than 1 matlab t is between -1 to 1. Any value between -1 to 1 will have the modulus up less than 1. So -1 up to +1, the signal value is constant and that is equal to 1. So that means the given signal xt is nothing but a rectangular function having the total duration 2. This is what is the total duration, t, that is 2. So rect of t by 2. Rect of t by 2. So what is the Fourier transform of this? What should be the Fourier transform of this? X of omega कितना हो जाएगा? Sampling, as I told you, sampling omega into t by 2. t का वैल्यू 2 रखा तो this is sampling omega. लास्ट में साइन में कन्वर्ट कर देंगे. This is sampling omega. Then property. Then the property. तो यहां पे प्रॉपर्टी का भी मिक्सचर है. गुड क्वेश्चन इट इज. x of 2t convolution x of t by 2. Okay, right. So what should be y omega? Convolution means multiplication. First x 2t Fourier transform 1 by 2 x omega by 2, right, into x t by 2 Fourier transform 2 x of 2 omega. Again the time scaling property, correct? x 80 property. So ये हो गया 1 by 2 and 2 तो सर कैंसिल कर दिया मैंने. What is the x omega by 2? What is the x omega? Sampling omega. So this becomes sampling omega by 2 and x2 omega means sampling 2 omega. Options आपको साइन के फॉर्म में दिख रहे हैं तो let's convert it to the sign. Let's convert it to the sign. Sin omega by 2 upon omega by 2. What is sampling x? Sin x by x directly. Sin x by x into sampling 2 omega means sin 2 omega divide by 2 omega. Okay, so कितना हुआ ये? Okay, omega square 2 and 2 cancel. Okay, so 1 upon omega square, right? It is the 1 upon omega square. 4 कहीं से missing हुआ है क्या? Just let me check up. xt is 1. Oh, sorry. This term is missing. I am so sorry. Just misprinted I have done. T sampling omega t by 2. Right, that is the t sampling omega t by 2. The t will come here. Just ये टाइप नहीं किया मैंने, so let me again retype it. t. Okay, the t will definitely come here. Okay, so if xt is right t by 2, the x omega will be 2 sampling omega into 2 by 2. That is 2 sampling omega. That is 2 sampling omega. Right, तो यहाँ पे देखो 2 आएगा, नहीं इसको ऐसे ही रखते हैं. 2 यहाँ आएगा 2 and into 2. Right, this is into. Right, so 2 2s are 4. So the answer is 4 upon omega square sin omega by 2 sine 2 omega. 4 upon omega square sine omega by 2 sine 2 omega. Option number A. Option number A, Shravani, correct. Okay, that is t sampling omega t by 2. Correct, everybody. So the option number A is absolutely correct. The option number A is absolutely correct. Next one. Okay, this is again a good question. For a function gt, everybody, for a function gt, correct, Sandhya, Charu, correct answer, Shravani. For a function gt, it is given that integral minus infinity to infinity e power minus j omega t. Arey boss, what is this? It is given that sometimes the language will be twisted. It is given that integral minus infinity to infinity gt e power minus j omega t dt. This is basically the Fourier transform formula, na? This is basically the Fourier transform formula. So what is given to you is the Fourier transform of gt, that is g omega. That is basically g omega. Okay, so this language should be very clear. So what is the g omega? Omega e power minus 2 omega square. Omega e power minus 2 omega square for any real value. Right? If yt is integral minus infinity से t g tau d tau. Right? अब integration property आएगा यहाँ पे. Now what is next given to me? Sir, if the y of t is integration minus infinity से t g tau d tau, g tau d tau, then what should be the value of y omega? Then what should be the value of y omega? So integration property, correct. Integration property क्या बोलती है? Integration of g tau d tau will have the Fourier transform g omega upon j omega plus pi g0 del omega. Integration property is the attribute. Integration property of the Fourier transform. The integration property of the Fourier transform, everybody, correct? G omega upon j omega plus pi g0 del omega. Plus pi g0 del omega, everybody. Pi g0 del omega. ठीक है, check करते हैं आप. Next thing. Now this is what is the y omega. Okay, no issues, sir. Absolutely no issues. So g omega is already given to me. ठीक है, अब एक और प्रॉपर्टी आएगी यहाँ पे. देखो, what is y omega? Let us place the g omega. Omega e power minus 2 omega square upon j omega plus pi g0. So what should be g0? g0 देखो ना, g0 will be 0. यहां से आप चेक कर सकते हो. g0 will be 0. ओमेगा को 0 रखा. So pi into 0 into del omega. So that is finished. Okay, so what is the y omega? Is e raised to the power minus 2 omega square upon j. Correct? Omega also cancelled. Yeah, you can say y omega is minus j e raised to the power minus 2 omega square. 1 upon j is minus j. अब question में पूछा है next property. What is the integration minus infinity से infinity? What is the integration minus infinity से infinity yt dt? What should be this value, guys? What should be this values? Everybody try to understand this relation. Okay. What is basically y omega? Any Fourier transform. It is integration yt e power minus j omega t dt from minus infinity to infinity. So just place the omega equal to 0. Next property, y0 is integral minus infinity to infinity yt dt, because e power 0 is 1. The e power 0 is 1. The integral minus infinity say infinity yt dt, and that is what is known as the area. That is what is also known as the area of yt. So we can find out the area, okay, by using y0. Okay, so this should be equal to how much? Integral minus infinity to infinity yt dt is y0. अब y omega है, omega की जगह 0 रखो, minus j e power 0 is 1. So my answer is minus j. Answer to the question is minus j, and that is the option number B. So this question is a combination of two properties. One is the area property and one is basically the integration property. One is basically the area property and one is basically the integration property, everybody. Okay, and also the basic definition. It is given that, what is given? सीधे बोल सकते हैं, it is the Fourier transform, but they are given in just a small twist form. Okay, it is given that what is given? Sir, Fourier transform is given. Simple. Okay, so these are good conceptual questions. Good conceptual questions. बहुत सारे simple भी ले रहे हैं. You know, that's what is the level of BARC. Many questions will be simple because timing is very small for the exam. But some questions, around 10-20 questions में थोड़ा सा twist होगा. So we are taking up the other variety as well. Next question on your screen. Consider a signal defined by. Okay, consider a signal defined by xt equal to e power jt. J10t for mod t less than equal to 1. What is its Fourier transform? This is also a property based question. This is also a sort of property based question. Can you attempt this? Can you attempt this question, guys? Quickly करते हैं. Okay, what is this signal actually? Let's try to write down this signal separately. Xt is e power j10t. Okay, let's write down e power j10t as e power j10t into 1 for modulus of t less than equal to 1. Okay, for modulus of t less than equal to 1. Okay, if I remove this part, okay, and if I write down a signal yt only equal to 1 for mod t less than equal to 1. अभी हमने sketch किया था ना इस signal को. When this signal is given 1 for mod t less than equal to 1, so that is a rectangle from -1 to 1 and its base is 2. So rect t by 2. Its base is 2. Rect t by 2. Correct है? So that is what I can write here. That is what? This is rect of t by 2. So what is the only difference in the signal xt? The xt is rect of t by 2 multiplied by the e power j10t. Time में exponential term, so it is the question based on frequency shifting. It is the question based on the frequency shifting. Rect of t by 2, that is the Fourier transform pair we always know. 2 sampling omega 2 by 2. T sampling omega t by 2 and 2 cancel. So this is 2 sampling omega. Now apply what? Apply the frequency shifting property. The frequency shift property e power j10t rect of t by 2 will have the Fourier transform x of omega minus omega naught. How much is the shift? 10. So यहाँ पे आ जाएगा omega minus 10. In the frequency shift property, the signs are opposite. If it is plus 10 here it should be minus 10. If it is minus 10 here, then it should be the plus 10. Opposite signs are there in the frequency shift. Time shift में same signs will go. So 2 sampling omega minus 10, and what is the meaning of sampling omega minus 10? Sin theta upon theta. So sin omega minus 10 upon omega minus 10. Answer is there on the screen. Okay, option number is 2 sin omega minus 10 upon omega minus 10. That's it. That's it. Basically the frequency shift property. So एक और property यहाँ पे cover किया. That is the frequency shift property. A, correct. Yes, Tarakasai, Dark Light, Shravani, Charu, Prabhnur. Correct answer A. बहुत बढ़िया. Okay. Cool. That is what is the next answer. That is what is the next answer. Okay. Next question. If xt is a positive rectangular pulse from t equal to -1 to 1, same rect t by 2 with the unit height as shown in the figure, but what is the value of integral -infinity to infinity mod of x omega square? -infinity to infinity mod of x omega square. Everybody tell me, what is the value of integral -infinity to infinity mod of x omega square d omega? Tell me. This is basically what? This is actually going to be solved by the Parseval's theorem. By the Parseval's energy relation. What is Parseval's energy relation, guys? Okay, the Parseval's energy relation, that is the energy in the time domain. The energy of a signal in time domain, that is integral -infinity to infinity mod of xt square dt is equal to 1 upon 2 pi integral minus infinity to infinity mod of x omega square d omega. Correct? Parseval's relation basically. Yes, guys. Correct answers are coming out. Okay. So the question is asking, integration minus infinity to infinity mod of x omega square d omega. So that should be how much? 2 pi into energy. Now what is the energy in the time domain? Because it's a rectangle pulse, that is why it is again simple. I told you the shortcut for rectangle, a square into d. Amplitude is 1. This is the total duration, that is 2. So a square d. So the answer is 4 pi. 2 pi into 2, answer is the 4 pi, option number D. For rectangle, always you can use the shortcut. Based on the Parseval's theorem, this question is Parseval's energy relation. Everybody. The Parseval's energy relation. Cool. Next question here. Let xn equal to minus of half power n un minus of minus 1 by 3 power n u minus n minus 1. What is the ROC of the Z transform of xn? One of the very commonly expected question from Z transform is the ROC. तो थोड़ा सा recall करते हैं. Okay, कुछ formulas को recall करते हैं, then you will take up the question. Okay, some revision of the formula. 2-3 important formula. So if you take a power n un right sided signal, what is the Z transform? Z upon Z minus a, or 1 upon 1 minus az inverse in the negative power form with the ROC mod Z greater than mod a. With the ROC mod Z greater than mod a, right? If you take minus of a power n u minus n minus 1, minus of a power n u minus n minus 1, या minus नहीं भी लो, minus right side लिख देंगे. So that Z transform is minus Z upon Z minus a, or minus 1 upon 1 minus az inverse, but with the ROC mod Z less than mod a. Mod Z less than mod a. Okay. And if you take a power mod n, what is the ROC? What is the ROC for a power mod n? A power mod n first of all has the Z transform Z upon Z minus a. No need to remember it. I'm just telling you a power n. Actually हम इसको कैसे लिखते हैं? A power n un plus a power minus n u minus n. Okay, sorry, u minus n minus 1. Okay. So next it is minus Z upon Z minus 1 by a. Z minus a inverse actually. Okay. And with the ROC. What ROC? Okay. With the ROC mod a less than mod Z less than mod 1 by a. Less than mod 1 by a, and with the condition कि mod a should be less than 1. Mod a should be less than 1. Otherwise the ROC does not converge. ये 3 ROCs आपके लिए important है. Right? The right hand side shows the ROC. Okay, so now tell me the answer for this. Right? Now whenever two signals are added or subtracted or multiplied, whatever it is, the ROCs will be, taken as the intersection. Okay. Right. Minus 1 power n un. What is the ROC? Suppose I say R1. The ROC is mod Z greater than mod A. Mod Z greater than mod A. ध्यान रखना. That is 1 by 9. Okay. Then minus 1 by 3 power n un. Minus 1 by 3 power n u minus n minus 1 है. What is the ROC? R1 mod Z less than mod A, that is minus 1 by 3, mod is 1 by 3. Okay, so what is the net ROC? It is known as the R1 intersection R2. Combining both, mod Z should be greater than 1 by 9 but less than 1 by 3. Okay, so between 1 by 9 to 1 by 3. 1 by 9 less than mod Z less than 1 by 3. Option number C is the correct answer. Option number C, right? Yes, Fasin, Tarakasai, Sheila, Shravani, Charu. Correct answer. Correct answer. Okay. Right. Yes, if that was the impulse response of a system, Tarakasai, then your argument is also correct. It is non-causal as well as unstable. Okay. Next question. If xn equal to 1 by 3 power mod n minus half power n un, then what is the ROC? What is the ROC? What should be the ROC? Everybody comment on this. What should be the ROC for 1 by 3 power mod n? For 1 by 3 power mod n, what is the value of a is 1 by 3, which is less than 1. Mod a less than 1. So that is why ROC will be defined. And what is the ROC? 1 by 3 less than mod z less than 3. Okay, and half power n un. Half power n un. What is the ROC? Mod z greater than half. So mod z should be greater than half, but between 1 by 3 say 3. Okay, so common लेंगे हम. When I take the intersection of them, okay, it should be greater than 1 by 3, but also greater than half. So half less than mod z less than 3. If it is greater than half, so it is automatically greater than 1 by 3. So half से लेके 3, answer number C. Answer number C. Just have to take intersection. Any doubt, please ask me. For any doubts, you can please ask me. Okay. Everybody. Next question. The response of a linear time invariant discrete time system to a unit step input is delta n. What is the response to unit ramp input n un? Tell me. Again, a basic question. You should be able to attempt it. Should be able to attempt it. चलो tell me. Yes, देखो, the response of a linear time invariant system to a discrete time system to a unit step input. अगर input unit step है, okay, suppose the system has the impulse response hn, okay, the output is delta n if the input is un. Okay, मतलब I can write down the equation here. Okay, the output delta n. अगर z transform में बात करें, what is the z transform of un? If I talk in terms of z transform, okay, suppose this is the xn and this is the yn, right? So what is yz? In the term of z transform, it is multiplication, input into gain hz. So what is the output? 1. Input z transform, unit step z transform, 1 upon 1 minus z inverse. Yeah, let me write it as z upon z minus 1 into hz, right? Into hz. तो यहां से hz आ जाएगा, यहां से hz is obtained. What is hz? z minus 1 by z. Okay, now the response of the system to ramp input. So if it is the same input, if it is the same system, sorry, okay, what is the output yn if the input applied is ramp input n into un? Okay, so this time the output yz is again input. What is the z transform of ramp? Z upon z minus 1 whole square. Basic z transform formulas you must know. hz का value आ गया z minus 1 by z. Okay, so everything is cancelled and I am getting 1 upon z minus 1. Okay, 1 upon z minus 1 can be written as z upon z minus 1 into z inverse. Z upon z minus 1 into z inverse. तो देखो, what is the yz? Guys, what is the yz here? yz हो गया z upon z minus 1 into z inverse. So what is yn? Time domain में चाहिए. Z upon z minus 1 is for unit step. Z upon z minus 1 is for unit step. But into z inverse, so time shift property. Z power minus 1 कब आता है? When you time shift by minus 1. So un minus 1. So the correct answer is un minus 1. Option number B. The correct answer is option number B. But please check up your answers, guys. Not everyone satisfied the correct answer. Option number B. Un minus 1. Correct answer. un minus 1, right? Okay, un minus 1. Yes, Tara Kasai, correct. Some of you are leading up to C and D also. No, correct answer is option number B, un minus 1. Simple and decent question, you can say. Next question पे आ जाते हैं. If xz is equal to 1 upon 1 minus z की power minus 3 is the z transform of a causal signal xn, then what is the value of x2 and x3? For a causal signal, okay, whenever there is a causal signal, what is the Z transform? It is summation of xn z ki power minus n. In general, minus infinity to infinity, but for a causal signal, the summation is 0 se infinity, na? Because it is causal, it does not exist on the left hand side. Matlab, the Z transform for a causal signal can be written as x0 into z ki power 0, okay, x1 into z ki power minus 1, x2 into z ki power minus 2, x of 3 z ki power minus 3 till infinity. That means I can say that any of the coefficient xk is the coefficient of z ki power minus k. x2 z ki power minus 2 se aayega. x3 is the coefficient of z power minus 3. In general, xk is the coefficient of z ki power minus k. Right. So now given, let us take up this given signal x of z, which is 1 upon 1 minus z ki power minus 3, which is 1 minus z power minus 3 whole inverse. 1 minus z power minus 3 whole inverse. Okay, now expand 1 minus x whole inverse. The Taylor series expansions or the binomial expansion. It is 1 plus z ki power minus 3 plus z ki power minus 6 plus z ki power minus 9 till infinity. 1 plus x square plus x cube and etc etc etc. तो यहां से आपको समझ में आ रहा है कि the value of x3 is the coefficient of z की power minus 3 which is 1 and x2 is the coefficient of z की power minus 2. But sir, there is no z की power minus 2. That means x2 is 0. So 0 and 1, x2 and x3, 0 and 1. Sequence भी याद रखना, not 1 and 0. 0 and 1. First x2 and then the x3. Correct. Tarakasai, Charu, Pavitra, Vivek, Suchi. Correct answer, guys. B is the correct. So that can be the next type of question that I can frame here. Everybody. Okay. Moving ahead next. The Z transform xz of a sequence xn is given by 0.5 upon 1 minus 2z inverse. It is given that the ROC of xz includes the unit circle. What is the value of x0? ROC of xz includes the unit circle. Right. What is the value of x0? Un by 3. I'm not getting. Tarakasai, what's your question exactly? Yes, Tarakasai, what is your question exactly? Chalo. Tell me. It is given that the ROC of xz includes the unit circle. Okay, अब देखो, x of z is 0.5 upon 1 minus 2z inverse. So where is the pole of this function? 1 minus 2z inverse equal to 0. So z inverse is 1 by 2. और actually z की बात करें तो 2. Z equal to the 2. Z equal to 2. Okay. Right. No, Tarakasai, no. So if the pole is z equal to 2, then what is the ROC? For the pole z equal to 2, ROC के दो possibility हैं. Mod z less than 2, mod z greater than 2. Now it is given that the ROC, important point is ROC includes the unit circle. So which ROC will include the unit circle? What is the meaning of unit circle? Mod z equal to 1. So if you want the ROC to include unit circle, okay, this should be the correct answer. This will include mod z equal to 1. Less than 2 तो 1 भी आ जाएगा, but this is not including unit circle. Okay, so what I can say that the x of z is actually 0.5 upon 1 minus 2z inverse with mod z less than mod a, with mod z less than 2. गलती करा देगा ये question. This is a question to commit the mistake easily. So what should be xn? So what should be the xn? This is minus 0.5 a power n. कौन सा question हुआ ये? A power n u minus n minus 1. left sided ROC mod z less than 2 matlab left sided minus and minus 1 formula will come, right? So what should be the value of x0? U minus and minus 1, left sided signal will start from minus 1. So what is the value of x0? It is 0. What is the value of x0? Is simply 0. It is simply 0. Option number B. Option number B. Cool. Option number B. Done? Yes. Next question. Moving ahead to the next question. Right. Now the transfer function of a discrete time LTI system is given to you. Okay, and consider the following statements. अब आपको देखो simply इतना ध्यान रखना है. You may calculate the poles also, but that is not required because directly ROCs are given. Okay. What is the condition for causality? For causal system, ROC, okay, ROC should be right-sided ROC, मतलब exterior of a circle. Exterior of a circle, okay. And for stable systems, what should be the ROC? ROC should include unit circle. Okay. Combining causality and stability. For causal and stable systems, okay, ROC is exterior of a circle but also including unit circle. इसका final conclusion क्या होता है? I'm just giving you the brief conclusions, okay? I'm just giving you the brief conclusion. The final conclusion, okay, ROC should be exterior of a circle but including unit. So all the poles, that is only possible if all the poles lie inside unit circle. Directly note कर लीजिए अभी, all the poles lie inside the unit circle. From here also we expect one case. All the poles lie inside the unit circle, everybody. Okay, so for this question, let us see the correct and the incorrect options. The system is stable and causal. Mod z greater than half, yes, causal. Mod z greater than half matlab 1 is also allowed, including 1. Greater than half any value, so it can also take the value 1, so it is stable also, yes, true. Okay. Mod z less than 1 by 4, it is not causal, correct. Okay, but it is stable. Mod z less than 1 by 4 means mod z cannot be 1, so this is not stable. So option number B is false. Overall it is false. Statement number 3, 1 by 4 to 1 by 4. It is the exterior of a circle. No, this is a ring shaped ROC, so it is not causal, correct. Okay, it is not causal, correct. And then, does it include the unit circle? Between 1 by 4 to 1 by 2, will you have the unit circle? No, unit circle is at 1. So it is neither stable, correct. So this is also true. It is neither stable nor causal. So option number C, statement number 1 and 3 are true. 1 and 3 are true. Second is false. Okay, option number C. According to the option, it is the option number C. Next question. Consider the digital filter structure shown below. Consider the digital structure shown in the below. What is the value of K for the system to be stable and causal? Abhi maine bola na, stable and causal. All poles, okay, within unit circle. All the poles should lie within the unit circle. Then the system is stable and causal. Okay, so I'll have to find out its transfer function. I'll have to solve it up slightly. This is xn, suppose the z transform is xz, okay, and this is yn having the z transform yz. Let this be the intermediate signal having the z transform wz. So this is what is coming here, wz inverse. So देखो equation बन जाएगा यहाँ से. Okay, what is going here? There is an equation of w is equal to x output of the summing point to x, and then what is coming other? Minus k by 3 w z inverse. Okay, ये एक equation हो गया. Okay, from here let us take w common on the left hand side. 1 plus k by 3 z inverse is x. Now coming to the y equation, what is y? It is equal to again w plus output of the summing point where one is w and one is coming from the below path, that is minus k by 4 w z inverse. So from here I take w common, 1 minus k by 4 z inverse. Okay, so what is the output y? I need to place the value of w. I need to place the value of the w, so it will become 1 upon 1 plus k by 3 z inverse, okay, into w, and then sorry, w is replaced by x. This will be x, na? X upon 1 plus k by 3 z inverse into 1 minus k by 4 z inverse. Now the answers are there. What is the transfer function of this? The transfer function is the ratio of the output z transform to the input z transform, and y upon x, dividing x on the left hand side, you have 1 minus k by 4 z inverse upon 1 plus k by 3 z inverse. So what should be the pole here? 1 plus k by 3 z inverse is 0. So z inverse is equal to 3 by k, or you can say that the pole is k by 3. Minus k by 3. Okay, but the pole should be within unit circle. We need mod z less than 1. All poles must lie within unit circle. That means mod z should be less than 1. Unit circle means mod z equal to 1. Okay, so all the poles should satisfy mod z less than 1. Mod z less than 1. Mod z कितना हो गया? K by 3. After taking the mod, minus is removed. Okay, less than 1. Mod of minus k by 3 less than 1, eventually k less than 3. K less than 3. Correct answer is B. Mod k less than 3, sorry, only minus sign is reduced, but k का value mod लगा लेंगे हम. Mod k less than 3. Option number B. Option number B. Option number B. This can be one stability based question. Okay. Acha. Now, basically, what is the Z transform formula? Next question ahead. What is the Z transform formula? X of Z. X of Z. That is equal to summation of xn z raised to the power minus n from minus infinity to infinity. Right? Where Z is the complex variable r e power j omega. Right? R e power j omega. Right? If we evaluate the Z transform over unit circle, what is the evaluation of Z transform over unit circle? Okay, over unit circle. Over unit circle matlab modulus of Z less than equal to 1. Acha, what is the mod Z? In the Euler form, R is the 1. So let's take R equal to 1, and this gives you Z equal to e power j omega. Okay, then you get this function, that is the x, Z ki jagah e power j omega, x e power j omega as summation minus infinity to infinity, summation minus infinity to infinity, xn e power minus j omega n, z equal to e power minus j omega. Okay, so e power plus j omega, the z ki power minus n is e power minus j omega n, is basically the discrete time Fourier transform, the DTFT of xn. This is basically the DTFT of xn. ठीक है? If xn equal to half power n un and yn equal to x square n, okay, y e power j omega be the Fourier transform of yn, then what is the value of y e power j0? देखो समझने की जरूरत है इस क्वेश्चन को बस. What is given to you? Y of n is x square n. अच्छा, DTFT और IDTFT, पहले मैं दोनों फॉर्मूला बता देता हूं आपको. दिस इज द DTFT. ओके, लेट मी जस्ट राइट डाउन बोथ द फॉर्मूला. व्हाट इज द DTFT? एज आई हैव टोल्ड यू, x of e power j omega, or we also write it as x of omega. Ultimately it's a function of omega, na. X of e power j omega or x omega, it is known as it is known as the summation of xn e power minus j omega n. And then what is the IDTFT formula? Inverse DTFT formula. Okay, what is the inverse DTFT formula? Inverse matlab finding the xn. So what is the xn? It is written as 1 upon 2 pi integral over 2 pi x of omega e power plus j omega n d omega. Integral over a period of 2 pi. Either period of 2 pi matlab, what is this integral over 2 pi? It is either integral 0 se 2 pi, or you can take it as integral minus pi to pi, whatever it may be. Because the DTFT is always periodic with the period of 2 pi. ये भी पता होना चाहिए. DTFT is always periodic with the period 2 pi. It is always periodic with the period 2 pi. Okay. Chalo, so let's come back to the question. So yn is x square n, and what is the xn? Half power n un. So yn is the square of this. So what is actually yn? 1 by 4 power n un. 1 by 2 ki power 2 is un square will be un only. Okay, so what should be y of e power j omega? भाई व्हाट इज द DTFT? अगर आप इसका z ट्रांसफॉर्म लिखोगे ना तो 1 upon 1 minus 1 by 4 z inverse, राइट? z ट्रांसफॉर्म. तो व्हाट शुड बी द DTFT? 1 upon 1 minus 1 by 4 e power minus j omega. z की जगह e power j omega, राइट? Its z transform is 1 upon 1 minus 1 by 4 z inverse, फिर mod z greater than 1 by 4, which includes the unit circle. That is why the DTFT converges. It includes. DTFT will only converge if the ROC includes the unit circle. Acha, the question is simply what is the value of y e power j 0? तो ओमेगा की जगह 0 रख दो ना, तो 1 upon 1 minus 1 by 4, 1 upon 3 by 4, answer is 4 by 3, option number D. Option number D. Option number D is the correct option. Okay. Next question. A 5-point sequence xn is given to you. Let x e power j omega define the discrete time Fourier transform of xn. What is the value of integral minus pi to pi x of e power j omega d omega? Think about this. What is the value of this? What should be the value for this sample? Okay. क्या हो जाएगा? The value of minus pi to pi x of e power j omega n e raised to the power j omega n d omega, and then outside whole multiplied upon 1 upon 2 pi is the xn. That is what is the IDTFT formula. Now in this IDTFT formula I will put the n equal to 0. n को 0 रखा तो इंटीग्रल माइनस पाई टू पाई x of e raised to the power j omega n e power 0 is 1, d omega is known as the 2 pi x0. 2 pi को राइट साइड पे शिफ्ट किया. So what is the answer? 2 pi into x0. x0 given है क्या मेरे को? x0 is 5. So the answer is 10 pi. It's a basic property based question. Option number B. 2 pi. Correct. Fasin, Tarakasai, Kumar Kokila, Charu, correct. Shanmukh, just check it out once. It is 10 pi. Okay. चलो नेक्स्ट वन yes चालू correct. A system with the transfer function hz has the impulse response hn defined as hn given है आपको and hn कितना है आपको देखो hn is h2 and h3 given है only. Okay, only h2 and h3 तो मतलब origin also 0, everything else is 0. n equal to 0, this is the origin. Then n equal to 1 also 0. n equal to 2 पे 1 है, n equal to 3 पे -1 है. This is hn. Consider the following statements, whether it is a low pass filter or whether it is a FIR filter. Yes, whether it is FIR or not, yes it is FIR. Why? Finite impulse response having the finite number of samples. So yes, it is FIR. Impulse response has only 4 samples. Impulse response having the finite number of samples, so that is the FIR filter. Okay, but whether it is low pass or not, what is the technique of identifying? देखो फिल्टर पे एक क्वेश्चन हमने स्टेबिलिटी का किया था. दिस इज द नेक्स्ट वन. सो व्हेनेवर यू वांट टू टॉक अबाउट इन डिस्क्रीट डोमेन, इसको भी रिवाइज करते हैं पहले. व्हेनेवर यू वांट टू टॉक अबाउट इन द डिस्क्रीट डोमेन, okay, what is the low frequency? Omega equal to 0, right? And what is the high frequency? Because of periodicity, we know that the DTFT will exist only from -pi to pi and then thereafter repeat. DTFT is always periodic, so we take the highest frequency as pi, thereafter it is just the repeated analysis. So low frequency 0, high frequency omega equal to pi. Now if the low frequency is 0, if you convert into Z domain, Z is equal to R का value 1 लेते हैं, Z equal to e power j omega 0, तो Z is 1. In the DTFT, Z is e power j omega की जगह pi रखा, so what is the high frequency? Z equal to -1. E power j pi is -1. And take any intermediate frequency. That you can take any. Okay, so let's take omega equal to pi by 2. Exact बीच वाला ले लेते हैं. Okay, at omega equal to pi by 2, what should be Z? Z is e power j omega, e power j pi by 2, and e power j pi by 2 is j according to the Euler formula. Take any intermediate frequency just for checking up. So either you can solve this filter question in the omega domain, omega 0 and pi is the low and high frequency, or in the Z domain, Z1 and -1, low and high frequency respectively, intermediate frequency Z equal to j. अब आप एक काम करेंगे. Okay, let us calculate the Z transform for this. H of Z. Okay, so that is 0, 0. Then ये है n equal to 0 ना, तो 0, 1, 2. Then you have 1 into Z raised to the power -2 -1 Z power -3. Summation x and Z power -n. Summation of the x and Z power -n. So what is the Z transform? It is Z की power -2 minus Z की power -3, or it is 1 upon Z square minus 1 upon Z cube. ठीक है, that is the hz. Now let me rewrite this. Hz is 1 upon Z square minus 1 upon Z cube. So low frequency Z equal to 1. Okay, so what is the h of 1? 1 upon 1 minus 1 upon 1, that is 0. So definitely no Tarakasai. It cannot be the low pass filter. Definitely it's not low pass. Whether it is high pass or band passer, I don't know, but it is not the low pass, because the gain at the low frequency is 0, so it is blocking the low frequency. High frequency Z equal to -1. What is the h of -1? So 1 upon -1 का square minus 1 upon -1 whole cube. Okay, so that is 1 minus यहाँ पे -1 and that is 2. Okay, so it is passing the high frequency with considerable gain. It can be high pass. Okay, even if you want to check the intermediate frequency, so Z is equal to J. What should be the value of h of J? That is 1 upon J square minus 1 upon J cube. 1 upon J square is -1 minus 1 upon J cube. J cube is minus J. So ये हो गया -1 plus 1 by J, and 1 by J itself is -J. Okay, but what is the modulus? Complex value है, तो we need to check the magnitude spectrum. Modulus आ जाएगा root over 1 square plus 1 square, that is root 2. So if you nearly try to sketch, okay, if you nearly try to sketch modulus of h omega, how it is going to come, हालांकि मैंने solve उसमें किया है z में, but you will sketch it with frequency. Filter question means sketch with frequency. The modulus of h omega starts with 0 for omega equal to 0, right? And then it rises. Highest value that I have obtained is 2 actually. It rises and it has the final value of 2. At the omega equal to pi, its value is 2. Okay. And at omega equal to pi by 2, its value was root 2. Its amplitude was root 2. So that is what basically is a high pass filter. It is a high pass. It passes the high frequencies. Correct? It just passes the high frequencies. Cool. Okay. So this is false and it is FIR, it is true. So only S2 is true. Option number A is correct. Only the S2 is true. That is the option number A. Correct? Only the option number A. Only the S2. Next one. If you have understood this, please answer me the next question. The direct form structure of a FIR, finite impulse response filter, is shown in the figure. The filter can be used to approximate what type of filter? Low pass, high pass, band stop. So you have to get the gain here, you have to get the transfer function here. Previous case, impulse response is given, here the direct form structure is given. You can just solve up the equation of the structure and get hold of the answer. Achha, what is the meaning of this unit delay? What is the meaning of this unit delay? Z inverse. What is the meaning of unit delay? Z inverse. Unit delay means Z inverse, na? What is the meaning of unit delay? Yn equal to x of n minus 1 is known as the unit delay, na? Delay by 1 unit. So what is the y of z? Is x of z, Z inverse. So ratio of output by input is Z inverse. That is the gain. That is the gain. The unit inverse means Z inverse. So if xn, suppose this is the Z transform xz. Okay, so this becomes 5x. Okay, यहाँ पे आ गया x multiplied by 2 times Z inverse. Cascade में है तो gains are multiplied. So this is 5x Z power minus 2. So what is the output equation? Y. Okay, plus है पहले. What is the plus? 5 of x. Okay, and then minus 5 of x Z power minus 2. What is the transfer function? H of z. Okay, it is given by the ratio of output to the input z transform. X से divide कर दिया तो 5 minus 5z power minus 2 और 5 common 1 minus 1 by z square. Now मैंने transfer function निकाल दिया. You have to just give me the answer. So let's start checking. Let us start checking for the low frequencies first. Low frequencies, I will put z equal to 1 and what is the value of h1? 5, 1 minus 1 by 1 square and that is 5 into 0 and that is 0. So it is not low pass, ye confirm hai. Z equal to minus 1 for high frequency. H of minus 1, 5, 1 minus 1 by z square. Okay, but minus 1 square is also 1. So 1 minus 1 is again 0. So it is neither high pass. It is neither passing low frequency, it is neither nor passing the high frequency. Okay, so what type of filter it is? Let us take the intermediate frequency. Z equal to j. H of j. 5. 1 minus 1 by j square. And that is 5. J square is minus 1. So ये हो गया 1 plus 1, 2. 5 2s are 10. 5 2s are 10. So it is passing some intermediate frequency with considerable gain. So if you approximately draw, if you try to approximately draw its particular frequency response as a function, okay, its magnitude response mod of h omega as a function of h omega, as a function of omega, low frequency gain is 0 and it rises to 10 and it drops again to pi. So this is the characteristic of which filter? This is the characteristic of band pass filter. it passes a band of frequency. Okay, it passes some band of frequency with considerable gain. Rest it reduces. It passes a band of frequency with considerable gain and rest it reduces. Arre, what happened? It's all fine. Thank you, Prince. Thank you. So it is the option number C, band pass. Option number C, that is the band pass. Everybody, okay? Band pass, right? Okay. So guys, one more thing I need to update here. One more thing I'll update here. Just a second. This is the link of the Telegram, and what I want from you is, this is the link of my Telegram. Many of you might be there. If not, you can join my Telegram group, and whatever are the more important topics you are looking for BARC. Okay. Yeah, daily this BARC series is going on. I took EMT day before yesterday. Yesterday Chandan sir took control system. I am taking signals today, and then many topics, expected questions, daily subjects are there. But what extra you require from me? Suppose I was planning, as I told you in the last EMT class, I was planning antenna session for you, especially for BARC. Okay. Yeah, whatever part you want, actually just tell me in the Telegram, because conducting the session for you and then just only 15-20 people live. Okay, it is for the students, guys. It is for the students. See, as an educator, I appreciate even a single student. That is why I did carry this class, because otherwise in the beginning I was seeing 10, 15, 20, sometimes 25. So I was feeling, yeah, for whom I am taking. But yeah, even a single student success is important for me as a teacher and as an educator. Okay. But rather you want more of the signals, like you want the DFT, FFT part, almost 1.5 hours I conducted. But if you want the more parts, DFT, FFT parts, okay, Laplace transform part, major areas are covered, but DFT, FFT karna hai kya, Laplace karna hai kya? If there is a major demand, throw me in my Telegram group, then I will plan for you, because it should be for the students. So unnecessary carrying forward also. Okay, I don't, does not make sense. Okay, so I appreciated all those who were live, whatever be the number was, and I carried for around 1.5 hours. I will stop for today, and if you want more topics, that is, mathematics is there. Mathematics is on Sunday. Mathematics is on Sunday. Most expected questions for BARC mathematics will be there on Sunday. Please make a note of it. Okay, Sunday ko hai maths ka session. Don't worry. Sunday math sessions are there. Okay. And that is for all branches. You can inform all other friends also. Mathematics is there on the Sunday. I will throw the mathematics link on the Telegram channel. Yesterday little bit control system stopped in between due to some issues, technical issues at Chandan sir place. Yeah, I'll ask sir and I'll ask the YouTube team to recoordinate it. Okay. So almost 1.5 hours done. So now let me know whether you want Laplace, DFTs, FFTs. Okay. And then we shall plan up more for you. Whether you want antenna, should I plan a separate antenna session for you? So if there is a demand, then I'll plan separately extra for you. Maybe many of the students are already revised, BARC exam is there. So if people need it, then we are live. If there is a topic maybe which people don't read it right now, then there's no problem. Okay, then there's no problem. Okay, so I'll take up your opinions if required. Mathematics is there on the Sunday. Okay, and that is for all branch. You can inform all your friends. Mathematics will be there on the Sunday. Okay, no worries. So that is what the Telegram group, I already shared you the link. And regarding to the Gradeup structured courses I mentioned in the beginning, that is the Vision Gate, Vision 22, Vision 23, all of the structured live courses available in one subscription ship. Subscribe to the Gradeup Super. Right. For more information of the Gradeup Super, it's available on the Gradeup app, and you can download the Gradeup app from the Google Play Store. Okay. Marathon is there. Marathon is there for measurement also. Okay, marathon for measurement is also there. So there is a complete schedule. Okay, tomorrow I think it will be networks. Okay, or Sunday or Monday. Sunday ko maths to extra hoga, but Sunday or Monday, any one of the day you have the measurement also. You can check the complete schedule of the series. You can completely check the schedule of the series, atomic series. Okay, so measurement will also be there. Tomorrow it will be network. Tomorrow, let me see if it is created, what time it is. I'll update you about the tomorrows. Tomorrow also, guys, just stay tuned to the channel. Stay tuned to the channel. Tomorrow there will be network, I know. Time and all exactly, you just need to confirm. Okay, so tomorrow will be network. Sunday, I think measurements will be there. Sunday, I think measurements will be there. So you can check up all those things. Okay, the complete schedule of atomic series you can download. Okay, and if you are subscribed to the channel, you can just see the tomorrow schedule also. Most likely network will be there. Okay guys, hello, bye bye. Thank you. Stay safe and take care of yourself.